Okay, ladies and gentlemen, today what we are going to learn how to do is we are going to learn how geometric shapes help me solve real-world problems. Now, I want you to get familiar with a few words. The first word I want you to get familiar with is the word angle. It says that an angle is made when two rays share the same endpoint. Now, you might be thinking to yourself, what exactly does that mean? Well, a ray, right here, is part of a line that has one endpoint and extends in one direction without ending. Now, what does that mean? Well, let's just take a look at this down here. What we can notice is that we have a point right there and a line that extends up with an arrow right there. That means that this line that I just drew, is going on forever in one direction, but it stops right there. Just going to go ahead and erase that. That's a ray. Now, when you have two of these rays, here's ray number 1, and here's ray number 2. When you have these two rays coming together, at the endpoint, it creates what we call, right up here, an angle. In fact, it even has the word angle, and it has this nice little box right there that shows that an angle is right there. The angle is this right there. Let me just erase that and show you a little bit more of that. Now I've changed the settings around just a little bit to show you a little bit more of what an angle actually is. So here's my first ray, and here's my ray's endpoint. Here's my second ray going up like that, and of course the endpoint is still right there. Where the two rays meet at, this is what we call the angle. So now what we can do is we can go ahead and call that endpoint where they meet at, we call the endpoint, is called a vertex. It's the shared endpoint is called a vertex. So again, you have your ray and your ray. We have the angle. We have the endpoints, and this endpoint right here, that is what we call the vertex. Now, you might notice it says here for our first set of directions, number 1, it says to use a rubber band to make a large square on a geoboard. And that's just what they did right here. They used it to make a large square on this geoboard. Now, if you take a look here, we can go ahead and we can actually find that there are a lot of different angles in this figure. Remember, the angle is where the ray comes together to meet that endpoint. So here's an angle. Here's another ray, endpoint, endpoint. Here's another angle. Here's a ray, another ray. There's your angle, another ray, and another. So you should see that this figure right now has 1, 2, 3, 4 angles. Now, these angles actually have a specific name. Let's just investigate that a little bit further. If you can fit a square or rectangle exactly inside an angle, notice how this index card fits exactly inside that angle. We put a little box right there, and we call this a square corner, or in math terms, we call this a right angle. So that's a right angle right here. Here's a right angle. That's a right angle. And that's a right angle. And we can go like this. There's our ray. There's our other ray. And let me just move this a little bit closer. Let me just go ahead and move this a little bit closer. There it is right there. There's my two rays. Now, what I can do is I can make sure that a square gets put right into the middle where that angle is. All right, so here I have a square right here. And we're going to go ahead and see if this angle that we created, remember our angle is where those two rays meet up at an endpoint. And that endpoint, remember, is called the vertex. We're going to see if the square can fit in there. If it fits in there, this is considered a right angle. So let's find out. And it fits. So we can call this a right angle. It is a right angle. Now you might be wondering to yourself, what happens if I get an angle that is not exactly a right angle? That's not exactly a right angle, so what do I do? Well, let's take a look. If we come back to where it says, use a rubber band to make a large triangle, a three-sided triangle on a geoboard that is similar to the green pattern block. Here's our triangle, and we made our triangle right here. There's our angles. Remember, they come together where the rays meet at each other. But you're going to notice something about this triangle. I want you to look really carefully at that and that, that and that, and that and that. I want you to think to yourself, if I took a regular square, if I just took a regular square, and I tried to move it into those angles, would it fit in there perfectly or would it not fit in there perfectly? Well, let's find out. I take my square and I move it down here. Uh-oh, we found out that this square does not fit in there perfectly. It does not fit in there even close to being perfect. Let me just get that out of here. All right, it doesn't fit in there perfectly. So this is actually, you're going to notice this angle right here, these angles right here are actually smaller than our right angles. Okay? In fact, we can call it, this angle is less than a right angle. So now it asks us, how many angles in this triangle are less than a right angle? Well, we know that this one's less, and this one's less. That means there are 3 right angles that are less. Now, the last thing they ask us to do in this lesson right now is they say use a rubber band to create a large hexagon on a geoboard that is similar to the yellow pattern block. We should know that a hexagon has 1, 2, 3, 4, 5, 6 sides. Here's our hexagon on the geoboard. And what we're going to do is we're going to use that index card. Here's our index card, or we can simply just use our square. And we're going to go ahead and see and compare an angle formed by 2 sides of the shape. Is this angle greater than or less than our right angle? So if we take our square, you're going to notice something. Wait a minute. Look at all of this extra space right here. Look at all this extra space right here. That means that this square actually, this square, ladies and gentlemen, actually does not fit in there because the shape of the angles, the size of the angles is actually too big. This actually is a little bit too big for our square, So that means that the angle is greater than the right angle. So you can have angles that are bigger than or greater than your right angle. And if we take the time to look at all of the sides, all of the angles, I should say, you're going to notice that this one's bigger, this one's bigger, this one's bigger, this one's bigger. You're going to find that there are 6 angles that are greater than a right angle. Okay? So now, let us go ahead and focus on this very last question. Talk about it. So our first question comes up and it says, can a triangle have two right angles? Remember, your right angle is where two rays come together at that vertex and a nice even square can fit into there. Now, I didn't do a very good job of drawing that, but you get the idea. So we're going to go ahead and check and see, can a triangle have two right angles? All right, well, let's see if this can fit in here. Well, that doesn't fit, so one, that's not there. And that doesn't fit. And that doesn't even come close to fitting. So we know that this triangle cannot have two right angles or more. But what about this triangle? You can draw a triangle like this. Well, let's check it. Hey, we can fit one right angle in a triangle. But the question is, can the triangle have two right angles? Well, let's find out. Nope. Nope. A triangle can only have one right angle because, and they're asking us to explain, because the right angle will only fit one time. Now, the next question is an interesting one. It asks us to give a real-world example of a right angle. So what we need to think to ourselves is, okay, where in the real world can we find the right angle? What I have here is I have some examples of, on the internet, of some examples of some right angles. Let's see if you can spot them. Did you spot the right angle here? How about the right angle there? It's just tipped to the side. What about the right angle here on these windows? Or what about the right angle at this intersection? How about a right angle on this board of Scrabble? So you can see there are actually lots of real-world examples of right angles. I hope you enjoyed this lesson. I enjoyed presenting it to you. This is the first time I've used this technology, the screencast technology, to present to you a lesson. I hope you learned something, and I'll talk to you later.